Okay, everybody, so we're going to do a quick run through of selection sorting, and that'll finish up our sorting method unit, and then we'll get into data structures. All right, so for selection sorting, you just have two steps. You look at your full array, you look at your array, and you take the smallest element in your array, and you just throw it in the front. All right, and we have a nice image here. So we have this array 64, 25, 12, 22, 11. You take the smallest element of that, put it in front, and then repeat the step on the subarray. So these four elements now, not including 11, that excludes that earliest element that you just put in the correct spot. All right. So how can we do that? Let's do public static void selection sort on an integer array. Again, this works just fine with a double array as well. I'm just keeping it for integers for the sake of simplicity. We'll have a for loop for int I equals 0. I is less than array dot length minus 1 I plus plus. We're doing this so that we can loop through our entire array. The reason why we do array.length minus 1 is because we don't need to check the final element in our array if we take all of the other elements and put it in the correct spot, because if every other element is in the correct spot, that last element also has to be in the correct spot. All right. In this for loop, I'm going to create an integer variable that I'm going to call my minimum index. I'm going to set that equal to I. All right. That's just going to be that, where we want to put our smallest value now. All right. And now under this, I'm going to put another for loop. This will be on int. Why don't we do it on just j? It's equal to I plus 1. J is less than array dot length j plus plus. All right, now essentially what this is going to do, this is going to look at every element other than that first one. All right, and we're going to see if it is smaller than what we have already. All right, so this first min index, this is like saying, hey, we're assuming this first one is we're assuming 64 is the minimum number. Then check the next number. Is that one the minimum? If it is, that's the new minimum number. Then check the next one. Is that less than our current minimum? If it is, all right, check that one instead. And keep doing that until you find your minimum number. And then after that, we'll do a swap. All right, so very simple. We'll just have a single conditional statement in here. It says if array at index j is less than array at our min index, then our new minimum index should point to whatever that element at j is. So j will be that new minimum index. All right, so we start off with a minimum index of 0. So we say, all right, index 0 has 64. That's our minimum. Then we check here. Is 25 less than that? It is. So now index 1 is our new minimum index. That's where we'll find our minimum value. Then we check. Is 12 less than that? Yes. So index 2 is where we'll find our new minimum value. Then we check. Is 22 less than 12? No. So 2 is still our minimum index value. And then is 11 less than 12? Yes. So then 4 is going to be our new minimum index value. And then once we figure that out, we'll just do a simple swap. We've done this in that first algorithm where we'll say just take the value at our minimum index, put it in a temporary variable for now, then say array of minimum index is equal to just that first value that we put. We'll just swap those out because we know whatever was there can just be moved to that new location. And then array I, whichever that earliest location that we're looking at, will be set equal to that temporary variable. And that's it. That's all we need to do here. Because now when it goes back up to the for loop, I is going to increase to 1. And so now the minimum index that we're looking at will be in this 1 index right here. We're completely skipping the 11 because we know it's already in the right spot. So now it's only going to check these 4 elements to find what the smallest one is, or rather it's going to do it here. So it'll say minimum index is 1, 25. Then it'll look, is 12 less than that? Yes. So 2 is the new minimum index. Is 22 less? No. So 2 is still the minimum index. Is 64 less? No. So 2 is still the minimum index. Then we'll swap this here. 25 will go there. And we do that again on that smaller subarray, then this smaller subarray. And then at that point, everything's good. All right. So just to test this in action, and I'm just going to copy and paste some stuff so that I don't have to retype it all. We'll have an integer array, we'll just call it A, and we'll use the one in the example. We'll run selection sort on A, and now what we can do is we could say for int I equals 0, I is less than A dot length, I plus plus, we could say system.out.println A and index I. Super simple. And you should see that these now print out in order down the list, 11, 12, 22, 25, 64. Beautiful. That means our array has successfully been sorted. All right, so that's the last sorting algorithm that we'll be looking at in this class. I just wanted to get a few simple ones out there for you so that if you ever need to do sorting in a computer science setting, you have 3 different options to do it. There are plenty more, and they're way more complicated but more efficient. But here's just a few simple ones for you. All right, please do not forget to complete the attendance today. Pop into the Discord if you have any questions. And yeah, I hope you guys have a great day. Bye.